Okay, so let's start with 12.26b. And you can see that we're changing the carbon skeleton here. We're going from a total of 1, 2, 3, 4, 5 carbons to a total of 1, 2, 3, 4, 5, 6 carbons. So we're increasing by 1 carbon. And, I was talking about adding carbons to the skeleton. And I think that in the last video, I said something like, oh, I never showed you how to make carbon-carbon bonds. That's not true. Actually, I have showed you how to make carbon-carbon bonds before, right? If we used a primary alkyl halide and acetylide or some variation thereof, right, we could make an alkyne that way. But whenever we did that, you had to add a minimum of 2 carbons in order to do that. And so we're definitely not using that technique to add only 1 carbon to the skeleton. So could anybody give me an idea of where you would start in this reaction? Or in this sequence, I should say. Where would you start? Exactly. We want to use methyl magnesium bromide, right? So methyl magnesium bromide. Yeah, methyl magnesium bromide. So that's our green yard. And then in the second step, I would accept aqueous acid or water. Doesn't matter to me. Put H2O or H3O plus. I would accept both. And what that's going to give you, though, is the alcohol, right? So we're going to add 1 carbon, but now we'll have an alcohol, and we want to convert that to the ketone. So I'm just going to erase all this spinach here. We want to go to the ketone, and really we can choose Jones oxidation, we could choose PCC, we could choose Desmartin periodinane. I'm just going to write PCC to make it simple. And you don't even have to include the solvent, dichloromethane. If you want to, that's totally fine. If you just put PCC, I would know that you know what you're talking about. All right, let's move on to something that's a little more involved. And we're going to go to 12.27a. So this one here, where we're starting out with 5 carbons. And in our final product, we need to have 6 carbons. So we're going to add 1 carbon. And so this problem is very similar to the last one, but we're starting out with an alkene, and we want to make that same aldehyde. So we want to be able to take this alkene, and we want to make, so we don't need to increase the number of carbons, but we want to make this aldehyde. Could anybody tell me, and it's not just one reaction, there's more than one reaction, how would I convert this alkene to this aldehyde? Could somebody get me started on a strategy? There's no way to do it directly. I've got to do a few reactions. Yes, absolutely. So what Tiana is saying is to do an anti-Markovnikov addition of water. I would agree with that, right? Because if we make the primary alcohol, then we can oxidize that to the aldehyde, right? So I'm going to move this aldehyde out of the way, and I'm just going to erase this. And I need a bigger arrow, don't I? So I'm going to put here, first step is going to be borane and THF. And the second step is going to be hydrogen peroxide and sodium hydroxide. And that is going to give me the primary alcohol that I need. And then I can oxidize that primary alcohol using Jones or Swern. Let's try Swern. For fun, we'll use DMSO and oxalyl chloride. And then in the second step, we'll use triethylamine, like that. And that's going to give us the aldehyde, like that. Now we've already seen the remainder of it. And so all we have to do is treat this with one, we'll pick methyl magnesium bromide. Step 2, we'll treat it with aqueous acid. That's going to give us the alcohol. And again, this is what we were looking at in the last problem. And so now we need to oxidize this to the ketone. And so we could use the Swern again. I'll just copy and paste this just to save myself. Well, who am I kidding? I'm not going to save any time, but whatever. We'll paste this in here. So a Swern again, and that is going to give us the ketone. And there you have it, my friends. So that's a total of what? 1, 2, 3, 4, 5, 6, 7, 8 steps. It's an 8-step synthesis. So 8 steps in question A. 8 steps. That's a lot. So now I'm going to have to go over to a blank document, and we're going to take a look at B. So let me just bear with me here. I'm going to go over to a blank document here. So now we're on. This is what did I call it? 12.29B. Anyhow, we'll just put B. And we're starting out with acetylene, and we want to convert that into a compound that has 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Yes. 1, 2, 3, 4, 5, 6, 7 carbons. And then we have our carbonyl group over here. All right. So what are some ways that we could do this, so that we only end up with one product here, right? We don't want to come up with a bunch of ways to make, a bunch of different compounds, because the problem with this compound, I think, is that if you were to try to make, it might be a knee-jerk reaction to make something like, having the triple bond and then having 2 carbons here, right? And so 1, 2, 3, 4, 5, 6, 7. To do something like this, it's not going to work, because then you'd end up with the carbonyl here, and then you'd also end up with the carbonyl there. So this is not going to be the right way to do it, to try to do a Markov-Nikov addition of water on a triple bond and then go through the enol and allow it to undergo tautomerization. There's got to be a better way to do that. So I'm going to erase all this spinach here and ask myself, is there a better way to do this? What I'm thinking is, if we were to think about removing these 4 carbons here, if we could make this aldehyde, right, then we could just treat it with butyl magnesium bromide, right? This part here could come from butyl magnesium bromide. Then we could just do a Grignard reaction and then just oxidize, with whatever. And so the question then becomes, well, how do I get from acetylene to this compound? This is called propionaldehyde or propanal. Both names are acceptable. Anyhow, so how would I add 1 carbon to acetylene? Can anybody help me out with that? Because here I have 2 carbons, and then I need to have 3 carbons. Yeah, absolutely, right? Absolutely. So my students are saying that's a chapter 9 reaction, right? Way back in chapter 9, we learned to use sodium amide to do the deprotonation. And then in the second step, you would use iodomethane. Yes, and that would give you propyne, right? And then if we want to convert this into the aldehyde, could anybody help me out with that? We know a way to do that, to convert this directly to the aldehyde. If we do the anti-Markov-Nikov addition of water on the triple bond using 9-BBN, yes, absolutely. All right, if we use 9-BBN, that's going to give us an enol. I'm going to take the time to draw the enol for us. So it's going to give us this enol, but that enol is not stable. It undergoes tautomerization to give us the aldehyde. And then if I want to add the 4 carbons to it, all I have to do is treat it with butyl magnesium bromide. So this compound here, or this Grignard reagent, you could write it at 1, 2, 3, 4, and then put this. If you want to write it the whole kit and caboodle like that, just so it kind of helps you out, there's no problem with that. So there's your butyl magnesium bromide. And then in the second step, we'll put in some aqueous acid. And that's going to give us the alcohol. So 1, 2, 3, 4. And then 1, 2, 3, like that. And now to oxidize this to the ketone, choose your poison, I guess. What's something we haven't used? We haven't used desmartin periodinate. So we'll put DMP. And that would be it. If you said, I use Jones, fine, no problem. You do that. That works. Give me a thumbs up if you follow me, at least on the rationale of this synthesis. Does everybody follow me on at least the rationale? And I'm sure you're sitting there going, yeah, I'm going to have to study it on my own. Absolutely. Absolutely you will. If you didn't, I'd say that's pretty crazy if you didn't have to do that. All right. I said that C was in the same vein as the ones we just looked at. So let's skip ahead to D. All right, so there's the solution. Let's count this up. 1, 2, 3, 4, 5, 6, 7 steps. So this one is 7 steps. Let's take a look at C. So let's see here, no pun intended. So C was starting out with a secondary alcohol. Looked like this. Right, are we talking about how to master organic chemistry or what? Just one practice problem after another. So we're starting out with a total of 5 carbons in our starting material, and we end up with 1, 2, 3, 4, 5, 6. So we know that this must involve a Grignard somewhere But the problem is the hydroxyl is in the wrong spot, isn't it? Right, we have to move the hydroxyl over to the end, right? So if we have this compound, right, then we could make, I'm running out of space here, but we could make this aldehyde, right? And then we could treat that with methyl magnesium bromide, and then we could oxidize that. So then the question becomes, how do I get from this secondary alcohol to the primary alcohol? Well, the primary alcohol must come from the alkene. So I've got to find a way to make this alkene, and then I can do an anti-Markov-Nikov addition of water across it. Could anybody help me out with this reaction? I want to take a secondary alcohol and make a terminal alkene. This is going back to chapter 7. Yes, absolutely. Right, convert it to a tosylate is really the only way to do this. You can't use sulfuric acid because, well, I'll write down the right answer first. So Tiana says tosyl chloride, pyridine, and then the second step, we treat it with potassium T-butoxide, a big old hindered base. If you were to use H2SO4 and cook that up, that's going to give you, right, that's going to give you the Zaitsev product. So that's no good. You don't want that. So just erase all that. Okay, so now to go from here to the alcohol, we just need to do an anti-Markov-Nikov addition of water. So we'll put borane, THF, followed by H2O2 and sodium hydroxide. That is going to give me my primary alcohol. Then to oxidize that to the aldehyde, I'm going to pick PCC just because I'm running out of space. And that's going to give me this aldehyde. All right, now to get to the end, I'll put all the steps in here. The first step is going to be methyl magnesium bromide. Then I'm going to treat it with aqueous acid to do the proton transfer. And then to oxidize it, I don't know, we've used PCC, we've used Swern, we used Desmartin periodinane. I guess we could use Jones reagent just to do something new. So sodium dichromate, sulfuric acid, and water. There you go. So that's a total of 1, 2, 3, 4, 5, 6, 7, 8. So again, this is an 8-step process. 8 steps. All right. Is that enough steps for you? 8 steps. Later on, we'll look at reactions where we have more steps than these, but not too much more than 8 steps. Maybe 10 steps would be the most that we would cover in this class. So what I'm going to do now is stop this. Boom.